Good morning, my dear students. I'm Sridhar, your physics teacher. In today's class, in the chapter vectors, we are going to discuss numericals on the addition and subtraction of vectors. So if you can recollect, in the previous class, we had a discussion on the theory of addition and subtraction of vectors. So now we'll explore the numericals, means how to solve if a question comes, how to solve that particular question. So maximum, I'll try to demonstrate like what are the problem solving methods involved in this addition and subtraction of vectors. Let me start the class. So once again, good morning, kids. In the chapter vectors, we are going to discuss the problem solving in addition and subtraction of vectors. So let me begin with the numericals. Okay, let me read out the question. We have, because the resultant of P bar and Q bar is R. If Q is doubled, R is doubled. I think comma. When Q is reversed, R is again doubled. Find the ratio of P is to Q is to 1. Find the ratio of the vectors P, Q, R. So now if you can check it. So here, better I think I suggest like everything should be through diagram. It'll be, you have to work out. So that will be in a better position. Better position in sense, solving problem will become a little bit easier for you if you take help of diagram. So there's the P bar vector. There's a P bar. Next we have, there's a Q bar. P bar, Q bar. The resultant of these two is R. This is R bar. The angle between these two vectors is theta. And this is Q1. The angle between vectors is theta. Okay, let's do one thing. So what is this? R square equal to P square to PQ cos theta. Next case, if Q is doubled, R will be doubled here. So if Q is doubled, R will be doubled means I think we should just say sir, is it compulsory I should draw the diagrams? For our convenient, at least we can do some imagination. No? That was if Q is doubled, R will be doubled. So again, the P will remain as it is. The P will remain as it is. The Q will be doubled here. So you bring this Q double. I doubled it. Now proportionally the R will also get doubled. To R bar bar to Q bar. And this is as usual P bar. The angle between vectors will not change. That's what the condition given. So looking at this, what is the equation you can write? 2R whole square P square Q square 2Q whole square cos theta. Let's expand this one. So the expansion of this equation will be 4R square P square 4Q square 4PQ cos theta. Okay, this let me call it as equation 1. I'll number it equation 2. Okay, no, we'll go for that. If Q is reversed, again P is doubled. This will be P. This was the Q. Now Q is reversed here only by reversing it. So this will become Q bar, this P bar minus Q bar. Then the resultant what we'll get is, again, it will be doubled. Okay, this will become 2R bar. The angle between earlier was theta. Now what is the angle? Some other angle will come into picture. So what is this angle will be? 180 minus theta. Okay, now what is the resultant? How you write? P bar and minus Q bars are two vectors. So therefore this will become 2R whole square, P square, Q square, 2PQ. Cos of angle between them is 180 degrees minus theta. Cos of 180 minus theta minus cos theta. So minus 2PQ cos theta. 4R square. Okay, this is equation number 3. So no, okay, these 3 equations will prove. So I'll go for 2 and 3. Let me subtract like a 2 minus 1. So that P square I can eliminate. So first, now totally it's a mathematics, 2 minus 1, equation 2 minus equation 1. When we do this operation, so 4R square, 3R square equal to 3Q square, 3Q square, 4PQ, or this will become 2PQ cos theta. Say this, I am doing this one. 4R square minus R square, 3R square, P square get cancelled, 4Q square, Q square, minus Q square, 3Q square, 4PQ cos theta, 2PQ cos. The difference of that will be 2PQ cos theta. Okay, now we have everything. I'll write down this. Let's a bit. Yeah. So there's the equation 4. Then 1 plus 3, let me add, so that cos theta I can eliminate. So this will become 5R square, 2P square, 2Q square. Now I'm asking you to look at here. Minus 2PQ cos theta plus 2PQ, this will cancel out. So therefore this will become P square plus Q square. So we have this equation. P square plus Q square equal to 5R square by 2. So why you are doing all this? To get that ratio, so I should bring P in terms of R, Q in terms of R. Then only I can do something new. This one. So this equation we'll call it as 5. Three and 4, let me add up. 3 and 4, let me add up. Again, I'll go for 3 and 4. Equation 3 plus equation 4. 7R square equal to P square plus 4Q square. Equation 6, I'll write it. Okay, I think now we have equation 5 and 6. So using this, 5 and 6 all up, and we can get all the remaining things. So I'll substitute like from 5 and 6. Let me substitute the value of P square here. So 7R square equal P square will be 5R square by 2 minus Q square plus 4Q square. So if I send on this side 14 minus 5 will be 19 R square by 2 is equal to 3Q square. P square plus 4Q square equals 7R square. P square plus Q square equal to 5R square by 2. I think we have to solve this one, no? Relation between first Q and R, we got it. Okay, there's 2 14, no? Q square equal to what we get it as like a 3 root should come, no? P square plus 4Q square. Okay, let me do one thing. I'll simplify it somewhere. I'm not that good in maths. So 7R square, 5R square by 2 equal to 3Q square. Okay, yeah, fine. Now relation between R and Q is what we are trying to do. We are trying to get the relation between R and Q. 2 7 are 14, 14 minus 5 will be 9. 14 minus 5 will be 9, 9R square by 2. So therefore this Q will become under root of 3 by 2R. This value I'll substitute, if I solve it further, I'll get P equal to R. Now you see that what can be ratio? P is to Q is to R. Root 2 is to root 3 is to root 2. Like this, we can arrange them. Okay, I think the drawing diagrams, writing equations is something very, very important. After getting equations, again, you have to search how to get that relationship between all those quantities. I think there's a method I'm showing. You see that one. Say equation 1, 2, 3 writing is something very fundamental. After getting 1, 2, 3, then what you are going to focus on the writing. So like from how to get the unknown things is asking the ratio of people. So what finally we have to do, how P and Q are related, how Q and R are related. If you can get these two from, so you can use any method. I'm just showing one of the procedure here. Two forces each equal to F by 2 act at right angle. Their effect may be neutralized by a third force acting along their bisector in the opposite direction. What is the magnitude of the third force? I think this will be a problem, little bit relatively easier one. Two forces are there of equal magnitude. Then it will be acting at an, their effective may be neutralized. So what is the effective? Suppose that this is the force F by 2 bar. This force is F by 2 bar. How the resultant will be? So we'll go for shifting. If I shift this vector, it will come here. So then the resultant vector, where it will be? Resultant vector will come here. This is what the resultant, no? Then, so what is that resultant is equal to, when two vectors are perpendicular, the resultant is given by F by 2 whole square, F by 2 whole square. So this will become F square by 4, F square by 4 under root of this one. So this will become F by root 2. So this is the R bar. So now what is the magnitude of third force? So how the third force, I should bring it opposite to R bar. Then only it can be neutralized, no? Then it can be neutralized means, so the condition is here F bar, F by 2 bar, F2 bar. I should bring another vector which will neutralize it. This is what S bar, I'll write it. So what is that S bar? S bar should be equal to minus of R bar. So magnitude of that should be equal to F by root 2. Negative of vector, you should bring a force which is opposite to R bar. Then only it can neutralize these two. Let me take the next one. The resultant of two forces as magnitude 20 Newton, one of the forces of magnitude 20 Newton and makes an angle 30 degrees. I think that the priority should be again the vector diagram. So there is a one of the forces of magnitude 20 Newton, 20 root 3. And the resultant of both is how much? 20 Newton. And makes an angle 30 degree with the resultant. So the 30 degree is here. Look at this one. Then what is the magnitude of other force? Where the other force can be? Other force can make any angle, no? Here the other force is what? I'll going to bring it like this. this other force. So this is vector A bar, this is P bar, this is the resultant. So no, we know resultant, how much it is? 20 Newton. One of the force is magnitude, 20 root 3 Newton. The angle theta. Okay, let me write all the data so it'll be easy for us to simplification. Theta is how much? Is asking only to get the B, no? What is it? This is something I'll call alpha, sorry, because angle made resultant. So what is this angle? We don't know. So what is your approach? Your approach will be directly, sir, R square is equal to A square B square 2AB cos theta. That's all. B is unknown thing. Let's see what we can do. Then tan alpha equal to B sin theta, A plus B cos theta. What are unknown things? Theta and B are unknown things. You can solve by this method also. We know all the things, R, A, and alpha. Theta and B are unknown. Can we solve it? Yes, you can solve it. We have alternative here. Fine. So I think the diagram plays very important role. That's why I'm insisting on the diagram. Why don't you draw a diagram? The first priority is what you have to learn, rather than some writing equation and trying to think. And almost all this vector addition, subtraction, the formulas is what you know. The same basic formulas is what. First draw the diagram, write these formulas, look at the unknown things, known things, these unknown things, how you can relate. Or this is what the problem solving here is. Okay, this will be a little bit lengthy mathematically. We have to 2b cos theta. Here we have to substitute alpha value we know. Solving will get the answer. Let's do by other method. So here, these are the two vectors are there. I'm taking vector subtraction method. There's a vector addition method it is. What all I'm showing is vector addition method. Now, using vector subtraction, I'll show the same thing. Vector subtraction method. In the vector subtraction method, here I'll treat A bar and R bar as two vectors, and angle between them, let it be alpha. A bar is a vector. And R bar is a vector. This is a little bit smaller, no, of magnitude. Okay, this is, yeah, this will be more justified. So what is the angle between them? Angle between them is alpha. Now, I'll bring the B bar vector. The B bar vector will start like this. Okay, fine. Then what you're going to do? A bar plus B bar minus R bar equals 0. Yesterday, I think we have very nice discussion about these things. So A bar plus B bar equal to R bar. It is a similar same story. I'm interested in B bar. So what is B bar? You can write it as B bar. You can write it as R bar minus A bar. So R bar minus A bar is what will bring like this here again. See, you have to just spend. Okay, there's a minus A bar. What is the angle between R bar and minus A bar? This is that angle phi. So what is phi? Phi should be equal to 180 minus alpha. Alpha is 30 degrees. Okay, directly will bring it, will keep it this one. So what is our formula will be vector subtraction R bar minus of A bar is what we are doing. So this will become, the formula will be, okay, yeah, this is B square R square plus A square plus 2B 2RA. What is the angle between R bar and minus A bar? Cos of 180 degrees. Alpha. Okay, this is B square. There is unknown thing. A square 2RA. cos of 180 minus alpha will be minus cos alpha. Now b square, b value is 20 root 3 whole square, 20 square. B we don't know, sorry. This b square. A is what? 20 root 3 whole square. 2 the value of R is 20 root 3. Cos alpha is 30 degree, root 3 by 2. Okay, this is the cos alpha value. Solving this, we'll get expression for B. P will be 20 Newton. So able to understand now? there are many approaches are there. You have to analyze it. You should analyze it. Okay, now we'll take the next numerical. So I'm just demonstrating like how to solve the various problems. Try to follow the method is what the teacher is insisting here. Two forces P and Q act at a point such that P is reversed, the direction of resultant is turned through 90 degrees. Prove that magnitude of forces are equal. I think we'll speed up things. Just will speed up. Two forces are acting at a point. Such that if P is reversed, the direction of forces P and Q, we don't know what are the values, no? So this will be P. This will be vector P. This is Q. That's a bit longer. P I'll make longer. Okay, let this be Q. Now this is P, this is Q bar. So that if P is reversed, the direction of resultant is turned to 90 degrees. So there is a what like so now the resultant, what is the resultant? Resultant is here. It is the resultant of so let me call this as R1. Now after rotating this one, the direction of resultant such that if P is reversed, only P I'm going to reverse. So let me reverse the P. Let me reverse the P. So after reversing, so it will be minus P bar. You see this? Then what is the angle between? So earlier there was some angle, no, between them. I'll call theta. Let me call this is alpha 1. Then this new angle, let me take that as phi. Then there will be new resultant also will be there. Okay, the new resultant will take this color. And that new resultant, how it will be? It will be perpendicular to this vector. So this will become R2 bar. I'll put like this. So this is the 90 degrees. This angle, I don't know this. Let me call this as beta 1 or say alpha beta. This is angle made by the resultant with the vector minus P bar is beta. Angle made by the resultant R1 bar with the vector P bar is alpha, let it be. So these are and theta is the angle between vectors. So we have all this particular information. Let's keep this in mind. Now we have to write straight away the equation. What equations we have to write? Look at the first question again. Once again, you have to read question. P bar. Now prove that magnitudes of forces are equal. P and Q, how they are related. So we have to bring a set of equations here. What is the best formula we can take help of? I think better to take help of the angle made by the resultant tan alpha. This one tan alpha, what we can write it as Q sine theta P plus Q cos theta. There's a one equation what we have. Let me put it. Looking at this diagram, tan beta, here. I'm asking you to look at here. Tan beta. So what we can write it as tan beta is equal to, again, the other vectors is q, angle between them will be sine of 180 minus. What is the angle between minus p bar and q bar? Angle between p bar and q bar is theta. Angle between minus p bar and q bar should be 180 minus theta. So this will become tan beta is equal to q sine theta by p minus q cos theta. Okay, somehow we are very near to this one. Look at the angles, relation between the angles. Alpha plus 90 plus beta should be 180. So therefore, what is beta? You can write it as 180 minus alpha. So tan beta, I'll write it as 180 minus alpha. Q sine theta, Q cos theta. Tan of 180 minus theta will be cot alpha. So I have equation, this I'll call it as 2. Let's multiply equation 1 into 1 into 2. Tan alpha, cot alpha will be 1, product of this. So this will be Q sine theta by P plus Q cos theta, Q sine theta, cos theta. So this will become P square minus Q square cos square theta equal to Q square sine square theta. P square equal to Q square cos square theta plus sine square theta, which is equal to, so finally what we can write, P equal to Q. I think that's what the proof he has asked. Okay, fine. Again the sense, the diagram, that's what I feel. This angle. So how do I come to know what equations I have to write? See, we don't know R1, R2, so no question of writing R1 square equal to P square plus Q square to PQ cos, because if you have information R1, R2, we could have done something. There's no such information. So therefore, this is the best suggestible. Two forces of magnitude P and Q are inclined at an angle theta. The magnitude of the resultant is 3Q. When the inclination is changed to 180 minus, the magnitude of resultant force becomes Q. Find the ratio of the forces. When the inclination is changed to 180 minus theta. So what do you mean by that? Like, okay, first we'll start with the, there is a vector P bar. There's a vector P bar. And we have other vectors Q bar are inclined at an angle. So inclined at an angle means the angle between the vectors is theta. The magnitude of the resultant is 3Q. This is a Q bar, P bar. The resultant of that is 3Q is telling. Resultant R1 bar equal to 3Q. Okay, this is the, so what you can say, like this is the, say, alpha 1, not needed, and we will write it. When the inclination is changed to 180 minus theta, inclination changed to 180 minus theta means the angle between vectors will become 180 minus theta. So before that, we'll write this equation, 3Q whole square is equal to P square Q square 2PQ cos theta. There's a one equation you keep in hand. Next, I'm going to change the inclination. The inclination means the angle between vectors is going to be varied. So how much I'm going to vary? This is P. Now it will become 180 minus, it will become 180 minus theta. So it will be 180 minus theta should be here. So this is the 180 minus theta. (180° minus theta). The magnitude of resultant force becomes equal to Q. So, sir, like what is the resultant, where it will be? So somewhere we'll put it here. The resultant R2 bar will become Q. magnitude, I'll write it. I should not. No, what is R2? Like here, how we solve this will be R2 square is equal to P square plus Q square 2PQ cos of 180 minus theta. This will become only Q square. Cos of 180 minus theta minus cos theta. So Q square get cancels, P get cancels. So we'll get the value of cos theta. Earlier, shall we add up these two? I think better. We'll get relation between P and Q. There's the equation 1 and 2. I'll add up these two. 1 plus 2 will become 4Q square. Here, you have to look at this one. 3Q square, 4Q square equal to. Then P square, 2P square, Q square plus Q square, 2Q square. This will become 2Q square equal to 2P square, or P equal to Q. Okay, fine. So this is the resultant of these two. A vector B which has magnitude A is added to vector A which lies along x-axis. The vector A which lies along x-axis. The vector A is along x-axis. And the vector B is added so that the resultant is along y-axis. You see this, the way things are there. And the vector B bar should be somewhere here. No, sir, you can ask me a question like, sir, on what basis you will assume that on what basis? So read the question. A bar is along x-axis. Magnitude A is added to this one. Then the sum of these two vectors is the third vector which will lie along y-axis. This will become y-axis, no? Vertical. So therefore, what is the angle between R bar and this one? So the first will go for the angle between the vectors, that is theta. This is what alpha, which is 90. And the price of A, and what is R equal to? R equal to 2 times of A. I think we have enough information to solve. But we don't know cos theta, how to bring cos theta. Let's see what all equations I can write. First, the magnitude equations, I'll write it. This R square is equal to A square plus B square 2AB cos theta. R equal to 2A whole square, A square, B square, 2AB cos theta. We don't know most of the things. Let me add it is. So 2A square, this will become A square, 4A square. Okay, this will be A square plus B square, 2AB cos theta. This is the equation 1. Now we'll take help of this tan alpha. Tan alpha equal to B sin theta by AB cos theta. Tan alpha, tan 90 equal to B sin theta. A vector B has a magnitude Find the magnitude. Okay, we know magnitude also. Okay, I'll substitute in there, no problem. This will be a plus b cos theta. Now you see this. This will become infinity or 1 by 0. Tan 90 will be infinity or 1 by 0. So therefore, a plus b cos theta equal to 0, or b cos theta equal to minus a. Call equation 2, that put 2 in 1. So when you substitute 2 in 1, you're going to substitute b cos as a. That one. So let's solve the next step. This will be a square b square. 2a. B cos theta, I'll write it as minus a. So this will become a square equal to b square minus 2a square. So 3a square equal to b square. So therefore, a equal to b by root 3. What is the value of b? In fact, b is equal to how much? It was 8, no? I think some mistake happened. 4a square will become, this will become 3a square. 3a square, 3a square, this will become 5a square. This will become a equal to b by root 5. I made some correction. So here we went wrong. 2a square will become 4a square. No, 4a square minus a square will be LHS 3a square. This will be our answer. Read the question, this one carefully. Result of two vectors A and B is perpendicular to vector A, and its magnitude is equal to half of the magnitude of vector B. The angle between A and B is, I think some correction is there. This is not beta, no, it is not needed. This is angle between A bar and B bar is what we have to find out. So what we can do here, directly let me take formula, because alpha will be here 90 degrees, because R is a resultant, no? So therefore the tan alpha equal to b sine theta by a plus b cos theta. Now you can ask questions, sir. What is theta? Theta is angle between a bar and b bar. Here, what is the theta? Theta will come like this. This total. I'm unable to, or we'll draw one diagram. This is a bar. This is R bar. And the resultant, and this is B bar. So what is a theta? Theta will come like this. This is theta. This is the alpha. This is R bar. This is A bar. This is B bar. Tan alpha 90 degrees. So tan 90 infinity. So this will become 1 by 0. B sine theta. I think everyone knows this mathematics. Tan 90 is equal to infinity. Infinity, can you write 1 by 0? That's what I did here. Huh? Okay, therefore, what we can write, a plus b cos theta equal to 0. The angle between a bar and b bar, we want that theta. Okay, let's come for the resultant formula. R square equal to a square b square 2ab cos theta. Let's see that what all. The resultant of two vectors a bar and b bar is perpendicular vector, and its magnitude is equal to half of the magnitude of vector b bar. So what is R equal to? Actually, R is given as b by 2. So let's substitute b by 2 whole square, a square, b square, 2ab. So we don't know b cos theta what to do, minus a. From where? From this one. So further what you can write, b cos theta equal to minus a. This, look at here, that I'm going to substitute here. I think it's everything now clearly. So b square by 4 minus b square equal to a square minus 2a square. So this will become 3b square by 4 equal to minus a square. The angle between a bar and b bar is needed. So what is b is equal to, what is a equal to? A equal to b root 3 by 2. So I have this equation. This I'll substitute here. B by a is root 3, no? Or cos theta is equal to minus of a by b. What is a by b? One more step. Let me add up. A by b is root 3 by 2. Substitute here. So theta should be equal to 150 degrees. Cos of minus root 3 by 2 should be 150 degrees. So this is our answer. We have to just keep on solve them. Nothing is there. Just draw the diagram, work out thing. And the sum of, I read the question. So it will be the sum of magnitudes of two forces acting at a point is 60 Newtons. Sum of magnitudes means if I take the vector a plus b 16. The resultant of these forces is perpendicular to smaller force and has a magnitude of 8 Newton. The smaller force is magnitude of x, then value of x. One is smaller. Okay, the resultant of this smaller. The resultant is perpendicular. So definitely you have to first bring resultant. It'll be easy for you to bring the other vector. The other vector where it should be now. So the other vector has to be here. So r equal to 18 and this much of information is there. Is asking to get the value of e. There's the only available thing we have to find out. I think we have this much of info. We have to proceed now. So what are the equations we can write? Again, this angle between the vectors is theta. This is what alpha. 90 degree. Again, the same thing they are going to help us. The same previous problem what we did. The similar way is what we can proceed here. A plus b is 16. So first we will write the equation. The resultant will be r square is equal to a square plus b square 2ab cos theta. R, the resultant is 18. 18 square. A square we don't know. B square we don't know. 2ab cos theta also we don't know. Keep it. Then come for tan alpha. B sin theta by a plus b cos theta. Tan 90. Do we know b? We don't know that also. Let's see what we can do here. Tan 90 is in fact 1 by 0, no? This tan alpha is 90 degrees. So tan alpha will be 1 by 0 will write. So therefore, a plus b cos theta equal to 0. Here. Look at here. Tan 90 will be infinity. Infinity will be 1 by 0. So anything multiplied with 0 will be 0. So a plus b cos 1 into a plus b cos theta equal to RHS will be 0. We ended. B cos theta is how much now? Minus a. This is what I'm going to, let me substitute here. So 18 square equal to a square b square 2ab cos theta is minus a. So this will become b square minus a square. So 18 square, b square minus a square, you can write b minus a into b plus a. B plus a is 16. So this is 18 into 18, b minus a. B plus a is how much? Is 16. So the value of this will be b minus a is equal to 18 into, we can do only 9 by 8. So again, this will be 18, 2, okay, 81 by 4. Now we have two equations, 81 by 4, a plus b equal to 16. Solving this will get a and b. So a will be 6, b will be 10 Newton. Smaller one is this one. No? This will be our answer. So almost I am what I'm doing immediately after reading the question, then we are going for diagram, then looking at the diagram, what are the known things, unknown things. We are writing equation, then we are taking help of mathematics, how we can simplify. That is the only method available to solve this problem. And the angle between two vectors is A and B is theta. Okay, there's a vector A bar, there's a vector B bar. The resultant of these vectors R makes an angle theta by 2 with A. There's no necessity. So there's a resultant. It will make equal angle is telling theta by 2, theta by 2. Then what about A and B? It should be equal, no? There's no need to fight further. Just you can directly say they're equal, or else you can do one thing. What is the angle made by resultant with vector A bar? Tan theta by, because alpha will become theta by 2. Angle between vectors will become theta. This is the angle between, already given, no? I need not to write. Let me write only alpha. So tan alpha equal to B sine theta, A plus B cos theta. So tan theta by 2 can be written as sine theta by 2 cos theta by 2. B, I'll write it as sine theta, I'll expand it as 2 sine theta by 2 cos theta by 2. Cos theta by 2. Cos theta by 2, what to write? Will become 2 cos square theta by 2 minus 1. 1 sine theta by 2 will get cancelled out. So this will end up with, we wanted relation between A and B, no? Here, A plus B. Two cos square theta by 2 minus B is equal to 2 cos square theta by 2, 2B. Here we'll write it 2B, and this is 2B. So finally A equal to B. Agreed, or else very simple, no? If the vector makes, if the two forces are equal, then the vector will make equal angle with both the vectors. Directly then A and B should be equal. I'm showing this mathematically here. After this, two vectors A and B are at an angle of 60 degrees with each other. Two vectors are there. So there's a one vector A bar, the other vector B bar. Then the resultant vector R bar, A bar, B bar at an angle 60 degrees. So the angle between them is 60 degrees. The resultant makes an angle 45 degrees and B equal to 2. Then what about R and A? We'll find out. We'll find out both. So what is the formula for angle made by the resultant with vector A bar should become equal to B sine theta. Sine angle between vectors is 60 degrees. Theta is 60 degrees. Alpha is here 45 degrees. B sine theta, A plus B cos 60 degrees. Value of B also we know 2 unit. 2 root 3 by 2. A plus 2 1 by 2. So this will become root 3 by A plus 1. Tan 45 is equal to how much? I'll write it here. Tan 45 is 1. This will be root 3 A plus 1. So all together 1 into A plus, so this will be A plus 1 equal to root 3 or A equal to root 3 minus 1. Okay, this is our answer. The magnitude of A is asking. Let me deal with the resultant of two vectors. The resultant of two vectors P bar and Q bar is R. If the magnitude of Q is double, the new resultant vector becomes perpendicular P. Then the magnitude of R is equal to. After when you double it, it will become perpendicular. Earlier it was not. So here, I think let me explain through diagram rather than just shouting. This is a vector P bar. Then what about the vector Q bar? Q bar is here. Then the resultant will be somewhere here. So this is P bar, Q bar, this is R bar. If the magnitude is doubled, it will become perpendicular. So now by shifting property of vectors, you try it. So this will be let me bring it here. You can see this. This let me take it out. I'll use this one. This is what here the vector is like this. Hope everyone is able to understand the what I mean to say here. Now I'm going to increase the length Q. Then it's going to get doubled. So how it is possible now? Now first we'll write some equation. We'll see what are the equations we can write. What is the angle between vectors? This is the angle between vectors. Theta. So what is the equation? You can write r square p r square equal p square 2pq cos theta. This much of information is what we have. Further, what we can write it as 2q p. I'll keep it 2q cos theta. The magnitude of r is equal to. We have to get that magnitude. So this much of information is what we have here. Further, let me solve the thing that one. I'm going to increase the magnitude. So that then I'll increase the q. If I increase the q vector, so I think here I'll take care of only this much is needed. This is the vector p bar. This was q bar. This was earlier r bar. If I increase the magnitude of what? Q bar is increasing. I've increased here. How much I'll increase so that it become r bar will become perpendicular. I think as this is what happens, no? I'll double it, that's all here. It was earlier Q. So now the new resultant, it will get doubled. So this will become perpendicular now. So earlier it was like a, so what is this vector will become 2Q. So this I'll take it out. This would be a new resultant. The new resultant becomes perpendicular to P. Only that much is there. I'll call this as S bar. I'll write it. I'm not bothered anything, sir. What is the angle? All. So how much magnitude? None of our business. So this is 2Q bar. Oh, this, as your length increases here, the R bar will rotate and will become finally perpendicular. Then how much R is asking equal to? So this 2Q vector should be here. No, you're going to bring it here. So actually it happens here. No, this is the vector P bar. 2Q bar is here. Sir, can you show R bar? R bar is here anyway. The same diagram. This is 2Q bar, this P bar. Angle between vectors didn't change. It remained same. Only the resultant has become 90 degrees. The new resultant, I'll call this as S bar. So what is tan alpha? This is alpha. So tan alpha is equal to 2Q sine theta P plus 2Q cos theta. This should be tan alpha. This should be, as alpha is 90 degrees. So this will become 1/0 2Q sine theta. So 2Q cos theta, what we can write? Minus of P/2. Or 2Q cos theta is minus P. Where I'm going to use? I'm going to use this in this equation. So finally, what do I get? Substituting this here. R square equal to P square Q square plus P minus P. So this will become R square equal to P square plus Q square minus P square. This will cancel out. R square equal to Q square, R equal to Q. This is our answer. You must have patience to draw the diagrams. That's what I feel. Vectors A bar and B bar include an angle theta between them. If A bar plus B bar and respectively subtend angle alpha and beta with A, then tan alpha plus tan beta. Oh, some questions. Yes. Tan alpha plus tan beta. I think you should immediately go to your trigonometry little bit. A little bit trigonometry help is what we have to take it. There's no other way. Vectors A and B. So I'll start like this. There's a vector A bar. There's a vector A bar. Vectors A bar and B bar include an angle. There's a vector B bar. There's a vector A bar. The angle between them is what? Theta. Then resultant of A bar plus B bar subtends an angle alpha. Okay, I think that this is, we are quite clear. So this is what the alpha, and this is what you should call a bar plus b bar. Then the minus b bar, the negative of this vector, minus b bar. Let me bring it here. Then a bar minus b bar, it will subtend an angle beta. No, where is the beta I to show? I to show the beta. It is here. Hope if you are able to draw this much of diagram. Sir, how come this resultant will be, I think, vector subtraction only? The vector subtraction only. If you had a bar, b bar, you get like this. No, I think everyone knows this. I think that almost we are going to end this vector addition subtraction. Minus b bar is there. Minus b bar, can you shift it here? Then what about this other vector? Other vector will come here, no? A bar, what is this vector? A bar minus b bar, no, it is. Oh, something happened. No, let's get into the discussion. So what is the thing? Tan alpha. We'll write some mathematics because these are the diagrams we know. Say, draw diagram. Then after drawing diagram, take help of any mathematics, formulas, or what I'm saying, mathematics, no, some formulas here. So therefore, tan alpha should be equal to b sine theta a plus b cos theta. This is the one equation. Then tan beta, vector subtraction formula should be equal to b sine of 180 minus theta. What is the angle between a bar and b bar? A bar and minus b bar. Angle between a bar and minus b bar is, how much is this? Finding difficult. Just put the angle. Now, what is the angle between a bar and minus b bar? See here. It's 180. No, theta is the angle between a bar and b bar. 180 minus theta will come here. So therefore, the angle between vectors is sine of 180 degree minus theta by a plus b cos of, no, sine of 180 minus theta will be sine theta. A minus b cos theta. I have equation 1. Angle, then tan alpha plus tan beta. Let me add up these two. Equation 1 plus 2. Tan alpha plus tan beta. B sine theta a plus b cos theta. B sine theta a minus b cos theta. B sine theta I'll take outside. A minus b cos theta plus a plus b cos theta all divided by a square minus b square cos square theta. So b cos theta will cancel out. So 2a, I'll get it. And this is a square minus b square cos square theta. The final answer will be 2ab sine theta this is a required expression. Sir, is it not math based? Maybe. We don't need this much of numerical, just some numerical practice is what we have brought it here. Let me shift to next question. Read the question. No, the next question is like the resultant of a bar plus b on reversing the vector b1, the result becomes r2. What is the value of r1 square plus r2 square? Resultant of a bar b bar is, there's a vector a bar, there's a vector b bar. Is r1. The resultant is r1. On reversing the vector b1, on the reversing the vector b bar, the resultant becomes r2 bar. Vector subtraction is what that will occur. So here this will become minus b bar. You better go take help of diagram. At least something will be there for you to learn. So what is the resultant vector? This will become r2. Previous problem we had a discussion that almost I think the similar approach. This is r2. So what is r1 bar? If you draw the vector, it'll be like this. A bar plus b bar, this r1 bar. Then this a bar minus b bar. This is what r2 bar, no? Then what is the formula? Looking at this, addition of vectors. Formula for addition of vectors, r1 square equal to a square plus b square 2ab cos theta. Subtraction of vectors, a square plus b square plus 2ab. What is the angle between a bar and minus b bar? If this is theta, what can be this angle? What can be this angle? 180 minus theta, or here I can show it. This angle is how much? If this angle is theta. So therefore, angle between a bar and minus b bar will become cos of 180 minus theta. Let's add up cos of 180 minus theta. What further we can write it? Minus 2ab cos theta. I'll add up these two. I think some simple mathematics, nothing to do. I'll read this question. Two forces of magnitude P and Q are inclined at an angle theta. The magnitude of the resultant is 3Q. When the inclination changes to 1, the magnitude of the resultant becomes Q, the ratio of forces P by Q. Okay, first will, as usual, my method is take help of diagram. This is P bar, next the vector, this is Q bar, are inclined at an angle theta. The magnitude of the resultant is 3Q. Three Q bar, I'll write it. It'll be better, no? This is P bar. This is Q bar. This is the angle between those two. Let this be alpha. If needed, we'll write it. When the inclination is changed to 180 minus theta, between what? Between P bar and Q bar. The inclination changed to 180 minus theta. So this will become The magnitude of resultant forces will become Q. So inclination, so where is the resultant force? The resultant force has to take certain will become only Q. Q bar. Okay, this is P bar. This is Q bar. This will be a little bit confusion. The resultant will become magnitude of that will become Q bar. Again, these two are not same. Okay, I'll write it. R2 bar, where R2 is equal to Q, you mean to say. Not like it will become Q bar. Now, what is this angle? This angle will be 180 degree minus theta. So let's write equation 3Q whole square equal to P square Q square equal to 2PQ cos theta. So this will become 2Q square equal to P square plus equation 1. Now similarly on this side 180 minus theta, what is the value will be? R2 square equal to P square Q square 2PQ. Angle between P bar and Q bar is now 180 degrees minus theta. This will become Q square from here. So this will become P square Q square cos of 180 minus theta cos theta minus PQ cos theta. Q square get cancels. So P square equal to 2PQ cos theta. 2PQ cos theta is equal to P. This is equation 2. Put 2 in 1. So 2Q square equal to P square. 2PQ cos theta is P square. The ratio of P by Q, no? So here if I do that, how much I'm getting equal? 1:1. There's no options. Okay, got it. 3Q square will become 9Q square. Oh, this will be 9Q square. Let me redo it from here. 3Q square will become 9Q square. 3 square should be 9. 9Q square plus Q square. This will become 8Q square. Okay, fine. No. Okay, I think we'll get it. Now 8Q square equal to P square. 2PQ square, you can write P square. So 8Q square equal to 2P square. So P by Q is equal to 4. Okay, 2 by 1. I had to be alert, maths. Okay, no problem. This will be our option. Two vectors. I didn't scribble it properly. I think that, okay, you are able to read it. Yeah. Two vectors A1 bar, A2 bar, each of magnitude A are inclined to each other such that the resultant is equal to root 2A. Find the resultant of A1 bar minus A2 bar. The resultant is equal to, so there's initially the two vectors are there. There's a vector A bar. There's a vector A2 bar. Such that the resultant is root 3A. The resultant is what? Root 3A. Yeah, we will write it. Root 3A. No, we can't. Let me use symbol. Then what is R1? R1 is equal to magnitude is root 3a. This is a1 bar plus a2 bar, no? So what is r1 bar, which is equal to a1 bar plus a2 bar? The angle between them is again theta. I think okay, it is some addition subtraction, nothing to don't bother much. So again, the r1 bar equal to a1 bar plus a2 bar. No, a1 bar minus a2 bar. So I should bring the negative of the vector a2 bar. The negative of vector a2 bar will be here. How the resultant of a1 bar minus a2 bar? The resultant of a1 bar and a2 bar should be r2 bar. Is asking that r2 bar is what is asked. Find the resultant of. No. What has to be done? So let's get into the r1. R1 will expand r1. If I expand the r1, r1 square equal to a1 square, a2 square, 2a1 a2 cos theta. This is what root 3a whole square, a1 square. We don't know this, 2a1 a2 cos theta. Each of magnitude. In turn, what is a1 equal to a2 equal to? It is a. The magnitudes are equal. Okay, this will become, I think, 3a square, a square, a square, 2a square cos theta. Cos theta will be equal to 1 by 2. If you solve this, theta equals 60 degrees. Now we'll go for the resultant R2 bar. R2 bar. What is the angle between? What is this angle? 180 minus theta. Angle between A1 bar and A2 bar. I'm asking, what is this? If this is theta, this angle should be 180 minus theta, 180 degree minus theta. So then the equation for R2 bar will be R2 square is equal to A1 square, A2 square, 2A1, A2 cos of 180 minus theta is the angle between A1 bar and minus A2 bar. This R2 is what we have to find out. This is A square, 2A square. Cos of 180 minus theta minus cos theta. Do we know cos theta value? 60 degrees. I'll substitute that one. So this will become further 2A square minus 1 by 2. 2A square minus A square is equal to A square. So what is R2? Equal to A. Very nice problem where you have to, again, the vector subtraction only. Vector addition, vector subtraction is what being applied. So what is this? This is the vector addition formula. Till here, everything is vector addition. This after this is vector subtraction. This is vector subtraction. If the magnitude of sum of two vectors is equal to the difference of their magnitudes, then the angle between vectors is okay. If the magnitude of sum of two vectors is equal to the difference of their magnitudes, I think we have to read question. This is something with the magnitude of sum of the two vectors. Magnitude of sum of two vectors means, I think, r square equal to a square plus b square 2ab cos theta. This r magnitude of sum of vectors. sum of two vectors is equal to the difference of their magnitude. Is telling this much. Then the angle between vectors. Hope, sir, how you wrote this? Magnitude of the sum of two vectors is equal. Sum of two vectors means he's asking the vector sum. What is our vector sum? Then again, is equal to the difference of their magnitude. Here not a bar minus b bar, a minus b. I think this is not a vector addition, it's a scalar addition here. This is a vector addition. Hope everyone is able to analyze. So let me substitute there. We'll see what we can get it. A minus b whole square equal to a square plus b square 2ab cos theta. So this will become a square plus b square minus 2ab cos theta equal to -1, theta equal to 180 degrees. No, if you want, you can draw a diagram, no problem. I have the resultant of two vectors. If there is a term two forces, a plus b and a minus b is root of a square. Then the angle between these forces is a plus b is one force. A plus b is one force. A minus b is one force. So here I'll begin like this. Let p bar resultant of two for p bar equal to a bar plus b bar. Q bar is equal to a bar minus b bar. I think this much is what there. The angle between these forces is being asked. The angle between these forces. So how do these forces are first? This is the vector p bar. This is what the vector q bar. If the resultant of two forces is root of its magnitude is telling. So here the resultant vector, we will show it from either P2 from P to Q. This is what, let me say R bar. What is R is equal to? That R is what equal to A square plus B square. Hope you are able to understand now. What is the angle between vectors is theta. Let me apply cosine rule. R square equal to P square plus Q square minus 2PQ cos theta. This theta is what needed. I have brought it. Theta is what? The angle between vectors. Theta is what? That angle between the vectors here. Okay, let's do one thing. Do we know R square value? Let's substitute the further calculation. So R square will be A square plus B square. P is what? A plus B whole square. P will become A plus B. Q will become A minus B. So what are two forces? Forces values are, I think the magnitude of forces, what is the magnitude of P is what A plus B it is. Again, what are A bar, B bar? Let's not bother. I'll take it out because he has not mentioned. He didn't write A bar plus B bar. It was written only P bar is a one force, Q bar is a one force. The magnitude of P is what? A plus B. The magnitude of Q is what? A minus B. I think this was the given. Let me stick on to the problem data. This will be A minus B whole square. 2 into A plus B. This A minus B cos theta. Okay, that theta is what we have to find out. That's the thing. Okay, that's expansion of this. A plus B whole square, A square plus B square plus 2AB. A square plus B square minus 2AB. 2 A square minus B square cos theta. 2AB get cancels if you see it, plus 2AB minus 2AB. So what will be left over now? On this side, this A square also will get eliminated. This B square, this B square. So what will be left over? The leftover terms are A square plus B square minus 2 times of cos theta equal to 0. A square plus B square, here 2A square minus B square. So therefore cos theta, what we can write? A square plus B square to A square minus B square. This is the value of cos theta. You have to write the equation, interpret diagram, then sine rule, cosine rule, Pythagoras theorem, all the basic maths. Randomly is what you should try to apply here. The resultant of two forces at right angle is 5 Newton. So 5 Newton means what shall I write? 5 is equal to, they are at right angle when vector A bar and B bar. The resultant is given by so what is R1? 5 Newton. So what is R1 equal to? Root of A square plus B square. The angle between them is 120 degrees. When the angle between 120, the resultant is root 13. I think this is the new situation now. Now is going to make the angle. What is the angle between them is 120 degree. A bar. This is a B bar. We don't know what, but the angle is 120 degrees. The resultant is how the resultant. Let's not bother the directional. So somewhere I'll put it here. This is the resultant. This R2 is root 13. Hope I think everyone is able to understand the conditions given clearly. The forces is asking to get the forces. So R1 equal to this much. So this will be 5 square equal to A square plus B square. What shall I write equation here? R2 square is equal to A square B square 2AB cos 120 degrees. What is R2? Root 13. So will become 13 only. A square plus B square 2AB cos 120 will be minus 1 by 2. A square plus B square is how much? Is 5 square. Okay, this will become equal to minus AB. So AB equal to 25 minus 13 will become 12. So what are the values I can make if A equal to 3, B equal to 4, A equal to 6, B equal to 2, or A equal to 4, B equal to 3. I think these are all possible options. We can do other things. So let me, I think there's one of the option which will satisfy. Okay, fine. So these are the set of the numericals which I just wanted to share with students. So you can try them on your own. So few more are there in the assignment there. You can try all those remaining numericals which are there in DPP, try to work out them. So as you start solving problems, you'll get a confidence. That's what the physics. Physics is all about the first reading the theory and immediately coming back to the numericals. You have to come back and start working numericals. As you work out different numericals, then that conceptual analysis will come into picture. Then you'll gain confidence. Okay, kids, like we had the discussion of the numericals in the addition or subtraction of vectors here. So how to solve the different problems, different conditions. So almost you can see then all the questions, what we did, whenever a question comes, what we did is like first we read the question, then the diagram. Then after looking at the diagram, some writing equations with the theoretical information, what we know. Then unknowns, then knowns and unknowns, will segregate them. Then what mathematics I can further bring it to solve that, so that the unknown quantity can be available from the known quantities. Seeing very easy, as you've seen, as you start problem, you have to think very different way. So everywhere some mathematics will be involved, that you have to be alert. Like you might have seen, I also did some mistakes here in the calculation. That happens. Gradually you can improve by the time exam comes. Okay, kids, like this is about the numericals. Okay, tomorrow I'll come with a new topic. Okay, we are going to discuss first the theoretical ideas of that, then we'll explore the numericals of it. Okay, thank you all of you. Take care, bye, see you.